Have you ever looked around and wondered if any of this is real? What if I told you that the universe we experience, the solid, predictable world around us, might just be a grand illusion? This isn't science fiction, it's what some of the most mind-bending principles of quantum mechanics are pointing towards. Get ready, because we're about to question everything you think you know about reality. So, what is this bombshell that quantum physics dropped on us? It's a concept called non-locality. Imagine you have two tiny particles, let's call them twins. They're linked in a special quantum way, a phenomenon called entanglement. No matter how far apart you separate them, even if one is on Earth and the other is on the other side of the galaxy, they remain connected. The instant you measure a property of one particle, like its spin, you instantly know the spin of its twin. It's as if they're communicating faster than the speed of light, which, according to Einstein, should be impossible. He famously called this spooky action at a distance. For decades, physicists wondered if there was a trick. Maybe these particles had hidden instructions from the start, like two envelopes, each containing a matching glove. You open one and see a left-handed glove, so you instantly know the other is right-handed. No spooky communication needed, right? This idea was called local realism, the belief that objects have definite properties, independent of observation, and that influences quantity travel faster than light. It's the common-sense view of the universe. But then came John Bell, a physicist who devised a brilliant test. Bell's theorem, as it's known, proposed an experiment that could definitively prove whether the universe follows this common-sense, local realism, or the spooky rules of quantum mechanics. And over the years, countless experiments, each more precise than the last, have been performed. The results are in, and they are stunningly clear. Local realism is wrong. The universe is, in fact, spooky. So, what does this mean for our reality? If particles don't have definite properties until we measure them, and they can be instantly connected across vast distances, then the very fabric of space-time might not be the fundamental thing we thought it was. It suggests that our perception of a solid, independent universe might be a projection from a deeper, more interconnected reality. Think of it like a video game. You see a 3D world on a 2D screen. The world you interact with is a representation of code running somewhere else. Some physicists now speculate that space-time itself might be an emergent property, a hologram projected from a lower dimensional surface where information is stored. This isn't just philosophical navel-gazing, it challenges our most basic assumptions. It suggests that consciousness and observation might play a far more crucial role in shaping reality than we ever imagined. If observing a particle brings its properties into existence, what does that say about our role as observers in the cosmos? Are we merely passive witnesses, or are we active participants in the creation of what we call reality? The idea that the universe isn't locally real is a tough pill to swallow. It forces us to confront the possibility that the world out there isn't just out there. It's deeply intertwined with us, the observers. The moon isn't necessarily there when no one is looking, at least not in the way we think of it. This journey into quantum weirdness shows us that the universe is far more mysterious, interconnected, and stranger than we could have ever dreamed. The reality we perceive might just be the surface of a much deeper, unseen ocean of quantum potential. What do you think? Is our universe a beautifully complex illusion? Let me know your thoughts in the comments below. Thanks for diving down this rabbit hole with Archivist Tech. Don't forget to like, subscribe, and hit that bell so you don't miss our next exploration into the mysteries of the cosmos. See you next time.